Hello friends, this video on coordinate geometry part 1 is brought to you by examfear.com. No more fear from exam. What we will study? We will study coordinate system, Cartesian coordinate system, distance between 2-point formula, sectional formula and area of triangle. Before we continue with our study, let's know what we already know. We already know that to locate the position of a point in a plane, we require a pair of coordinate axes, that is x and y. We also know that distance of a point from y-axis is called x-coordinates or abscissa. We also know the distance of point from x-axis is called its y-coordinate or ordinate. We also know that linear equation in two variable of form ax plus by plus c, if you plot this, it gives a straight line, and linear equation in two variable of form ax square plus bx plus c gives hyperbola. Let me repeat once again. Linear equation of two variable of form ax plus by gives straight line, and if this is form of ax square, this gives parabola. I'm sorry, this is quadratic actually. If you see, the maximum power is 2. Quadratic equation of two variables of form ax square plus bx plus c is a parabola. All these things we know. So if this is the coordinate system, Cartesian coordinate system with x and y axis, and if you see, all the points are equidistant in the x-axis. If this one is 1 centimeter, 2 will be 2 centimeter. The distance between 1 and 2 is 1 centimeter. The distance between 2 and 3 is also 1 centimeter. So whatever be the distance between 0 and 1, the same distance is there. So every point is, the distance between the consecutive points are same. Similarly in the y-axis, this is called positive x-axis because all the points are positive here. This center point is called 0, 0 because here both x and y are 0. This is the center point. And then you have this negative x-axis, you have this positive y-axis, and then you have this negative y-axis. This whole part is first quadrant. The whole, if you see the whole graph, is divided into 4 quadrants, 1, 2, 3 and 4. This is called first quadrant, this is called second quadrant, and this is called third quadrant, and this is called fourth quadrant. So they are fourth quadrant in the Cartesian coordinate system. And if you want to plot a point, let's suppose you want to plot this point is nothing, x comma y, right? X is called perpendicular distance from y-axis. So if this is y-axis, you draw a perpendicular line from here, correct? Let me draw it here like this. You draw a perpendicular line from here. You know the distance between this point and this point is nothing but 1, 2 and 3. So x will become, y is nothing but distance, perpendicular distance from x-axis. So from this point, draw a perpendicular to x-axis, find a distance. This is nothing but 1 and 2 units. So y becomes 2 units. So this point is 3, 2. So from 3, 2 we can very well tell that this is the point. So to locate a point we need x and y axis. X and y, that is abscissa and ordinate. Sorry. Yeah. Again, let's take one more example. Let's take this point here. So this point is also x and y, correct? To find x, what will we do? We have to find the perpendicular distance from the y-axis. This is 2 points. So x is 2. For y, we have to draw a perpendicular distance from x-axis. This is how many points? 1, 2, 3, 4, 5. So this is 5. This is xy, that is 2, 5. That's how it is, right? So shortcut is, instead of spending time in finding perpendicular distance and all, what we do is we use this. So if you see, if this is the point 3, 2, right? If this is the point, you see this point here, if you see, if you take this if you draw this line here, instead of finding the distance now, see the confusing here actually. See, for x-axis you have to find perpendicular distance from y-axis. For y you have to find perpendicular distance from x, right? So finding perpendicular distance calculating is difficult. So better what we do is, for x-axis, let's suppose for this point, you just try to see what is the value here in the x only. So in x-axis, see the value in x. Value in x. So if you see the value in x is what? 3. So this is 3. For y-axis, you just see this point. What is the value in y-axis? That is 2. So this is 2. So for y, you see value in y-axis, and that is 2. This is the shortcut way. But actually, going by the definition, this point is nothing but, x point is nothing but perpendicular distance from y-axis, and point y is nothing but perpendicular distance from x-axis. The way the xy graph is done, to find this point is, see this value is 3, right? Perpendicular distance from y-axis, and this is also 3. So to find this x, you can either find the perpendicular distance from y, or you can just see in the x-axis where this point lies. To find y also, if you see, you can either find perpendicular distance from x, find the distance, that is 1 unit, 2 unit, or you just see what is the value of this. If you draw this line like this, what is the value in y-axis? Correct? So when you are talking about perpendicular distance, the scene changes. For x, you have to find perpendicular distance from y. For y, you have to find perpendicular distance from x. That is little difficult, and that is little time taking and confusing also, because from x you have to find from y to find x. Don't do this. Just understand the concept that for x is nothing but perpendicular distance from y, and y is nothing but perpendicular distance from x. That is the mathematical definition. But when you actually want to find this value 3, 2, you just see, for example, if you have this point, right, you have to find the value of x and y, right? So if you see this point, you see this in x-axis, this is nothing but -4, you make it -4. But to find in y, if you see this point, this is 3, this is 3. This is very easy actually, compared to this one where you have to draw the perpendicular line and calculate the distance. Let's take one more simple example. So let's take this point let's say. So this is also xy, correct? Find the value of x. See this, what is the value of this point in x-axis? If you make this in x-axis, this is -2, y -4. This is, if you see, -4. And that is how we plot the point. This thing we have learned in the past classes, but since this is the base of the whole Cartesian system, so I spent some time on this. Correct? This is my Cartesian system, xy axis, origin is 0, 0, and it is divided into 4 quadrants. Now, before we start coordinate geometry, you must be thinking, why do we study coordinate geometry? What is the need of coordinate geometry? What will happen if we don't study coordinate geometry? Will I miss something in life? So let's try to understand, why do we need coordinate geometry in our life? Have you ever seen a scanner which scans the document, or a Xerox machine which give a photocopy of the pages? So all these things works on coordinate system. How it works, I'll tell you. Example, if you put an image here, and this image has some picture is there. For example, this is one person picture in this image. This is the image. So what the scanner actually does is, for each and every, this whole picture, it divides into xy coordinates, and each and every points will get one xy coordinate value, right? And then each small point will have some color, because this point will have red, this will have white, like that. And then internally it will apply some algorithm, some logic to convert this image into digital form. How it will store? It will store in this fashion only. For example, and this is a big file I have, where all this xy coordinates, for each xy coordinate, because each xy coordinate is a point, for each xy coordinate it will store the color, and then in that way the whole image will be stored. And that is how the image scanner works. It is totally on the basis of coordinate system. Also, if you see this digital camera, this also works on the basis of coordinate system only. I'll tell you how it works. For example, with this digital camera, you have taken this photo, right? This photo is a photo of a flower, let's suppose, or a guy. This is photo, the photo of a guy, a teddy bear, correct? And let's suppose this one, some figure is like this and something is like this, and one toy is here. Now what this camera will do is, the moment it takes the picture, this will come into its memory. But how this will be stored in digital system? Because if you see, everything is stored in the form of digital, right? You can take it and transfer in your computer also. Why? Because everything is stored in digital format. So what this camera does is, this photo, whatever it has taken now, to store in digital format, it converts this into XY coordinate. For example, this all are XY coordinates, different XY coordinates. All these points, right? For example, this, it will convert into, let's suppose, 10,000 points. And each point will have XY coordinates. And now if you see, some point has red color, some point has white color. And if it is a colorful photo, some point will have blue, some point will have black. So what it will do internally, for each and every point, it will store its value. For example, this point will have white, this point will have red, and then they'll have a software. When you try to see the image back, they'll try to assemble all the points, and once they assemble all the points, you'll get this image. That is how the whole digital world works. That is totally based on coordinate geometry. If you are not understanding the concept, it's okay, it's little hi-fi. Just try to understand that in your digital camera, in your scanning machine, in your photocopy machine, the coordinate geometry plays a critical role. If you want to go into that field in future, you should understand this coordinate geometry well. Also, if you see this construction business, the whole civil engineering thing, that works on coordinate geometry, because when they build flyovers, when they build buildings, they want to find a distance between, let's suppose, this point and this point, how much it will be, how much will be the elevation. Everything is done using coordinate geometry. Because the moment you say, talk about points, location of points, coordinate geometry comes into play. The moment you talk about distance between 2 points, coordinate geometry comes into play. So coordinate geometry is useful in this scenario also. If you want to move into civil construction business, you want to become civil engineer, coordinate geometry is a must for you. Also, if you see a real life example, you are a traveler and you want to find, let's suppose, distance between this point in Australia and this point in India. This will be Bangalore somewhere, or Delhi, let's suppose, this point in India. How will you find this? For this also you can use coordinate geometry. If you know the latitude and longitude of this point, point A, let's suppose this is point A and this is point B, and here also if you know the latitude and longitude, then you can find, using coordinate geometry, you can find the distance between these 2 points. Also, anywhere, if you want to find the distance between, let's suppose, this point in US with some place in Africa, you want to go to Africa and you want to find how far is Africa from this point in America. This is your city. How will you do? You will get the latitude of this and longitude of this point. Let's suppose that this point is C and this point also D, latitude and longitude, and then you'll use coordinate geometry to find the distance. So coordinate geometry is very, very helpful the moment you talk about points, the moment you talk about distance, the moment you talk about digital cameras. Coordinate geometry is very crucial. So I think with this you got a fair understanding of why are we trying to learn coordinate geometry and where can we use this coordinate geometry in our real life. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.